Hey, this is Horner, and I just want to go through number 1 through 10 for momentum. These are conceptual questions, and the first one says the momentum of an object is defined as just the mass times velocity. So you'll notice that in this we use P for momentum. Not really sure why, other than that's just what's standard. So they're going to use P for momentum. They won't use M mainly because it's for mass, and they won't use capital M either. So it's just P, which is momentum, is equal to mass times velocity. Do make sure that your units are always in kilograms, meters, and seconds. So for momentum, there's no unit kind of like a Newton or anything. It's just a kilogram times a meter per second, which is just mass times velocity. For number 2, this one says which has more momentum, a large truck moving at 30 miles an hour or a small truck moving at 30 miles per hour, and it's got to be the large truck, and that's mainly just because it has more mass. Even though it has the same speed, it does have more mass, so it's got to have more momentum. So that one's pretty simple. For number 3, compared to a sports car moving at 30, the same sports car moving at 60 miles per hour has twice as much momentum. So remember, the equation is mass times velocity, so that'd be 30 momentum units. 1 times 60 would be 60, so we just know that it's got twice as much momentum. For number 4, it says if the momentum of an object changes and its mass remains constant. So if the momentum changes and its mass remains constant, we have to know that this is P is equal to mv. So if the momentum is changing, so let's say the momentum is going up, then we know that the velocity is going up. If the momentum goes down, we know the velocity's got to go down, and that's because this is constant. And if this is constant, we know that P and V are directly related. So it is accelerating or decelerating because velocity is changing. There is a force on it, so the only way to have a force is to have an acceleration. And so if there is an acceleration, we know there's a force. And we also know that its velocity is changing. So this is the important part. That tells you that it's accelerating, and then the acceleration change tells you that there's got to be a force on it. So all those things come together. For number 5, it says, I gotta go back here, which of the following has the largest momentum? And then they're going to give you several, but the biggest one is going to be a pickup truck traveling down the highway. A large truck parked in a parking lot does not have any speed. If it doesn't have any speed, it cannot have any momentum. A tightrope walker crossing Niagara Falls, very small mass and very slow speed. And the science building, or just the wing of science here at the high school, it does not have any speed, even though it's very, very massive. For number 6, it says a freight train rolls along a track with considerable momentum. If it were to roll at the same speed but had twice as much mass, its momentum would be double. So here, let's say that the train is 1,000 kilograms going 10. That'd be 10,000 kilogram meter per second. And if you double the mass, then you'd also double the momentum. And that was kind of what you would see. For number 7, 2 objects A and B have the same size and shape, but A is twice as heavy as B. When they're dropped simultaneously from the tower, they reach the ground at the same time. But A has a higher momentum. It does not have a different acceleration, and they both hit the same speed. So remember, it doesn't matter. So if I have a small object and a large object, and they both fall in a vacuum, they would hit the ground with the exact same speed. So the speed here would be the same. The 2 objects in this one, though, are the same size, but one might be made out of something pretty light, and then the other one might be really, really heavy. Even though they have different masses in a vacuum, they would both fall the same distance, and they would have the same speed at the end because acceleration for both would be the same because it's just gravity. So A has the higher momentum because it has more mass. So its mass is really big compared to the other one. For number 8, this one says a 2 kilogram ball is thrown at 3. What's its momentum? So this is really easy, just 2 times 3, and its momentum would be 6 kilogram meters per second. For number 9, a 4 kilogram ball has a momentum of 20 kilogram meter per second, so they want to know what is the ball's speed. This one's pretty easy. We know P is equal to mv. So V would be equal to P over M, so that'd be 20 divided by 4, and that gives us 5 meters per second. Last question is a ball is moving at 6 and has a momentum of 24. What is the ball's mass? This time we're going to solve for M. So m, if you divide both sides by v, would be equal to p over v. M is then equal to 24 divided by 6, and that gives you your answer of 4 kilograms. And that is number 1 through 10 for momentum.